Hello students, let's see the question. Question number 1. AB crystallizes in the body-centered cubic lattice BCC with edge length A is equal to 357 picometer. Distance between the oppositely charged ions in the lattice is. Since it is a BCC, for metallic crystal we have got square root of 3A is equal to 4R. But if it is a ionic compound in BCC, then we can write 2 times radius of the cation plus 2 times the radius of the anion. Therefore, square root of 3a is equal to 2 times radius of cation plus radius of anion. So, therefore, radius of cation to radius of anion, the distance is d, distance between the oppositely charged ions in the lattice. Therefore, the distance is equal to square root of 3a divided by 2. Square root of 3 is equal to about 1.73 into edge length is given 387 picometer divided by 2, and this is approximately comes to be 335 picometers. Okay, so the answer is option number A. Question number 2. Lithium bromide crystallizes BCC lattice. Unit cell length is given. Atomic mass of cesium and bromines are given. Avogadro number is given. Therefore, density of the bromine we need to calculate. Now, what is the formula to calculate density? Density is equal to Zm divided by A cube Na. Correct? Right? Yeah. So, we are calculating density now. Now, what is Z value? It is a BCC. Assume cesium is there in the center of the cube, where bromine atoms are occupying the corners here, occupies the corner. If it is there in the center of the body, it is always 1 into 1 is equal to 1 particle. Bromides on the corners, 8 corners, contribute each corner particle is 1 by 8 is equal to 1. Therefore, total Z is equal to 1 plus 1. That means 1 cesium bromide formula. Okay, fine. What is how to calculate M? M is equal to cesium 133 atomic mass, bromine it is equal to 80. This comes to be 213, right? Edge length is given, which is equal to 436.6 in terms of picometer. See the options. In the option, all the units are in gram per cm cube, right? So this is the molar mass in terms of gram per mole. Therefore, I should write on A, edge length in terms of centimeter, not picometer. So therefore, 436.6 into 10 power minus 12 meters, right? Or 436.6 into 10 power minus 12, and 1 meter is equal to 100 centimeter. So therefore, it is equal to 436.6 into 10 power minus 10 centimeter, or we can write 4.366 into 10 power minus 8 centimeter, right? Now substitute density D is equal to Z is equal to 1 into 213 molar mass, A cube 4.366 into 10 power minus 8 cubic into any Avogadro number 6.022 into 10 power 23. On calculating, this comes approximately about 1.2 comes in terms of gram per cm cube. Okay. So what is the answer? Answer is option number 3. C is the answer. Okay. Question number 3. Second order Bragg's diffraction of X-rays with lambda is equal to 1 angstrom from a set of parallel lines in a metal occurs at an angle 60 degrees. Distance between the scattering planes in the crystal. Now, how to calculate the distance between the two planes in the lattice? So, for that, we have formula 2d sine theta is equal to n lambda. Okay, we have to calculate the distance, which is equal to n lambda divided by 2d. So, n divided by sine theta. They are given second order Bragg's diffraction where n is equal to 2 into lambda. We'll write down in terms of angstrom, 1 angstrom units divided by 2 into sine 60. Sine 60 degrees are equal to square root of 3 by 2. So it becomes square root of 3 by 2. Okay. So these two get cancelled. So this is equal to 2 divided by square root of 3 in terms of angstrom units, which is equal to 2 divided by square root of 3 is equal to 1.73 should be angstrom. This comes to be approximately 1.15 angstrom units. Okay. Therefore, what is the answer? Answer is option number D. Okay. Fine. Question number 4. If sodium chloride is doped with 10 to the power minus 4 mole percentage of strontium chloride, concentration of the cationic vacancies will be, Avogadro number has been given. Yeah. If you recall what you studied in the board syllabus, number of cationic vacancies should be equal to, okay, is equal to concentration of strontium chloride, okay, the doped material, concentrated doped material, okay. The concentrated doped material is equal to 10 power minus 4 mole percentage. The final answer in terms of, not in terms of mole percentage, final answer in terms of per mole everywhere. See here, per mole everywhere. Okay. So get rid of this percentage. So 10 to the power minus 4 mole percentage divided by, remove the percentage by dividing by 100. Okay. Which is equal to 10 power minus 6 in terms of mole comes. Clear? But answer is not in terms of mole. It should be per mole. And you know that if you take 1 mole of any substance contain Avogadro number. Similarly, 1 mole of cationic vacancies contain Avogadro number of vacancies. So therefore, 10 power minus 6, that 1 mole is equal to 6.022 into 10 power 23. And this is in terms of per mole. So much in terms of per mole, per 1 mole. So if you calculate this one, this answer should be approximately equal to 6 into 10 to the power plus 17 comes. Right? So what is the answer? Answer is option number B. Right? Clear? Question number 5. A metal has a FCC lattice. Edge length A is given is equal to 404 picometers. Density is given is equal to 2.72 in terms of gram per cm cube. Molar mass will have to calculate. Okay. What is the formula, students? Density D is equal to Zm divided by A cube Na. Correct? Yes. Density is given 2.72. Z value for FCC, you know that is equal to 4. Metallic lattice. So 4 into molar mass will have to calculate divided by, yeah. I will write out this edge length from picometer into the centimeter, because answer here density in terms of gram per cm cube. Okay. So this would be 4.04 into 10 power minus 8 centimeter. Correct. You know the conversion which I have done previously. So this is the 4.04 into 10 power minus 8 qubit. Avogadro number, you know, approximately 6 into 10 power 23 you multiply. So therefore, finally, when you calculate molar mass approximately equal to, it comes to be around 26, okay, point something, comes to be 26 point something. So closest answer is option number B. Second one is the answer, 27 gram per mole. Okay, right? Question number 6. The intermediate compound lithium silver crystallizes in the cubic lattice in which both lithium and silver atoms have coordination number is equal to 8. To what crystal class does the unit cell belong? Now, if the coordination number is equal to 8 for both, then it must be BCC lattice, right? Remember that. So the answer is option number C. Question number 7. Edge length is given is equal to 508 picometers. Radius of the cation is given is equal to 100 picometers. Then you have to calculate radius of the anion is equal to. Okay. Take the example of sodium chloride. If there is a chloride, okay, then there comes alternatively the sodium part. Then there is a chloride. Chlorides are there in the corners of the cube. Correct? Chloride to chloride distance is nothing but edge length actually. for ionic FCC lattice. Now this A is actually made up of 2 times the radius of the chloride plus 2 times the radius of the sodium ion, right? Therefore I can write this A is equal to 2 times radius of the cation plus radius of the anion. Therefore, radius of the cation plus radius of the anion is equal to A by 2. Edge length is 508 is given divided by 2, that is equal to, it is 254, right? Therefore, we have got radius of the anion is equal to this 254 minus the radius of the cation is equal to 254 minus radius of the cation is given 100. So therefore it comes to be 154 in terms of picometers. Right? So what is the answer, student? Answer is option number C, 154 picometer. Right? Please do subscribe, like and share the videos. Thank you. Have a nice day.